Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 4. Structural analysis. Questions and answer. 1. What is the displacement transformation matrix? The connectivity matrix which relates the internal displacement Q and the external displacement R is known as the displacement transformation matrix A. Q equals AR. 2. How are the basic equations of stiffness matrix obtained? The basic equations of stiffness matrix are obtained as equilibrium forces, compatibility of displacements, force displacement relationships. 3. What is the equilibrium conditions used in the stiffness method? The external loads and the internal member forces must be in equilibrium at the nodal points. 4. What is meant by generalized coordinates? For specifying a configuration of a system, a certain minimum number of independent coordinates are necessary. The least number of independent coordinates that are needed to specify the configuration is known as generalized coordinates. 5. Write the element stiffness for a truss element. The element stiffness matrix for a truss element is given by K equals AE/L. 6. Write about the force displacement relationship. The relationship of each element must satisfy the stress-strain relationship of the element material. 7. What is the compatibility condition used in the flexibility method? The deformed elements fit together at nodal points. 8. Write the element stiffness matrix for a beam element. The element stiffness matrix for a beam element is given by K equals 2, 2112. 9. Is it possible to develop the flexibility matrix for an unstable structure? In order to develop the flexibility matrix for a structure, it has to be stable and determinate. Compare flexibility method and stiffness method. Flexibility matrix method. Stiffness matrix method. The redundant forces are treated as basic unknowns. The joint displacements are treated as basic unknowns. The number of equations involved is equal to the degree of static indeterminacy of the structure. The number of displacements involved is equal to the no of degrees of freedom of the structure. The method is the generalization of consistent deformation method. The method is the generalization of the slope deflection method. Different procedures are used for determinate and indeterminate structures. The same procedure is said for both determinate and indeterminate structures. Is it possible to develop the flexibility matrix for an unstable structure? In order to develop the flexibility matrix for a structure, it has to be stable and determinate. What is the relationship between flexibility and stiffness matrix? The element stiffness matrix K is the inverse of the element flexibility matrix F and is given by F equals 1/K or K equals 1/F. What are the types of structures that can be solved using stiffness matrix method? Structures such as simply supported, fixed beams and portal frames can be solved using stiffness matrix method. Give the formula for the size of the global stiffness matrix. The size of the global stiffness matrix, GSM, equals number of nodes * degrees of freedom per node. List the properties of the stiffness matrix. The properties are as follows. It is a square matrix and always it should be a square matrix. It is asymmetric matrix. The sum of elements in any column must be equal to 0. It is an unstable element, therefore the determinant is equal to 0. The order of stiffness is equal to the number of coordinates. List the properties of flexibility matrix. Flexibility matrix is a square matrix of order n times n. Flexibility matrix is asymmetrical matrix. Elements of flexibility matrix may be positive or negative except leading diagonal element, which is always positive. Elements of flexibility matrix are displacements and they can be computed only if the structure is stable. If structure is unstable internally or externally, then displacements are indefinitely large and flexibility matrix does not exist. Why the stiffness matrix method is also called equilibrium method or displacement method. Stiffness method is based on the superposition of displacements and hence is also known as the displacement method. And since it leads to the equilibrium equations, the method is also known as equilibrium method. Define a primary structure. A structure formed by the removing the excess or redundant restraints from an indeterminate structure, making it statically determinate, is called primary structure. This is required for solving indeterminate structures by flexibility matrix method. Define degree of kinematic indeterminacy, or degree of freedom. It is defined as the least no of independent displacements required to define the deformed shape of a structure. There are two types of DOF. Joint type DOF. Nodal type DOF. Briefly explain the two types of DOF. Joint type DOF. This includes the DOF at the point where moment of inertia changes, hinge and roller support, and junction of two or more members. Nodal type DOF. This includes the DOF at the point of application of concentrated load or moment, at a section where moment of inertia changes, hinge support, roller support, and junction of two or more members. Briefly mention the two types of matrix methods of analysis of indeterminate structures. Flexibility matrix method. It is defined as the deformation produced for unit load. It is denoted by the symbols. This method is also called the force method, in which the forces in the structure are treated as unknowns. The No of equations involved is equal to the degree of static indeterminacy of the structure. Stiffness matrix method. It is defined as the force required for unit deformations. It is denoted by the symbol. This is also called the displacement method, in which the displacements that occur in the structure are treated as unknowns. The No of displacements involved is equal to the No of degrees of freedom of the structure. Define flexibility influence coefficient. Flexibility influence coefficient, F ij, is defined as the displacement at joint I due to a unit load at joint J, while all other joints are not load. Define element coordinates. Each element having a displacement along two directions, x and y, is said to be a element coordinates. Define global coordinates. For the whole structure having a displacement along the two directions, x and y, is said to be a global coordinates. What is meant by finite element method? Finite element method, FEM, is a numerical technique for solving boundary value problems in which a large domain is divided into smaller pieces or elements. The solution is determined by assuming certain polynomials. The small pieces are called finite element and the polynomials are called shape functions. Define displacement function. Displacement function is defined as simple functions which are assumed to approximate the displacements for each element. They may be assumed in the form of polynomials and trigonometric functions. Briefly explain a few terminology used in FEM. The various terms used in FEM are explained below. Finite elements. Small elements used for subdividing the given domain to be analyzed are called finite elements. The elements may be 1D, 2D, or 3D elements depending on the type of structure. Nodes and nodal points. The intersection of the different sides of elements are called nodes. Nodes are of two types: external nodes and internal nodes. External nodes, the nodal point connecting adjacent elements. Internal nodes, the extra nodes used to increase the accuracy of solution. Nodal lines, the interface between elements, are called nodal lines. Continuum, the domain in which matter exists at every point, is called a continuum. It can be assumed as having infinite number of connected particles. Primary unknowns, the main unknowns involved in the formulation of the element properties, are known as primary unknowns. Secondary unknowns, these unknowns are derived from primary unknowns, are known as secondary unknowns. In displacement formulations, displacements are treated as primary unknowns, and stress, strain, moments, and shear force are treated as secondary unknowns. Some important points related to structure. When a uniformly distributed load, longer than the span of the girder, moves from left to right, then the maximum bending moment at midsection of span occurs when the uniformly distributed load occupies whole span. For stable structures, one of the important properties of flexibility and stiffness matrices is that the elements on the main diagonal must be positive. When a load crosses a through-type Pratt truss in the direction left to right, the nature of force in any diagonal member in the left half of the span would change from compression to tension. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.